Hello, this is Matthew Zita,
And this is Faris Kazmi.
and this is our Aversion game. Let's begin by showing you what it looks like.
Aversion. You are light. Use WSD/arrow keys to move. Press the spacebar to travel. Asteroids move when you do. Good luck.
Alright. Here's our animation. You enter as a light, and this is the game screen.
Yeah. You can move around with WSD, and the goal is to dodge the asteroids that are coming. They're also moving when you move the light.
Alright, so I'm gonna press space. It looks like I can dodge it. It's cool animation. And it increases the number of asteroids as you beat each level. Alright, so once you get pretty good at this game, you get to this many asteroids, and the game starts becoming interesting.
Yeah.
And if the asteroid's too much for you and you hit it as such,
This is what happens.
you have died. Alright, well, let's quit and explain
How this works.
Now that you've taken a look at the game, one of the important things is to check for the collision. So here is the function to check whether the light hits the asteroid, and it actually uses a circular hitbox here. And to explain it further, I've got this wonderful sketch. And what it does is the circle has data points placed like this, and in the actual game there's 101 data points as such, and it's placed symmetrically like that. And how it checks whether a point is in the circle is first it checks this rectangle, and then it checks this rectangle, and then it moves along the circle to create a circular hitbox. It's similar to the Riemann sum in taking integration. So as it does this for each point of the sine graph, if there is a point, let's say it goes like this sine graph and this point. So when it's checking for this point, it knows that it's within one of the rectangles and it checks the collision that way.
So the next important thing we want to talk about is how we animated the light traveling.
And how'd you do that?
Well, for the animation, all we did is instead of plotting a whole wave of the sine, we plotted individual points and pausing between the displaying of those points. We can see here that all we do is plot a singular point which gets smaller over time, and then we pause and then we display that point all over again, which produces our light.
I see.
Amazing. One of the earlier versions of our game was this version, which used a cell array and asteroid images. It looks something like this. But the problem with this was that, first of all, it lagged too much, as you can see, and our actual code was not modularized at all and used a lot of global variables.
And the problem with the global variables, as you can see here, is it's just, first of all, a lazy way of coding. It doesn't use, it doesn't use functions properly. We're just passing everything unsecurely. And we found that a better way of coding is to use functions properly, and not here you can see we don't use any global variables. What we discovered in MATLAB is that it can implement graphical user interface through its built-in graphs.
So how we did our opening animation, where the light escapes the sun, is where we had an axis at the bottom of the screen, the x-axis. We moved its values, and it gave the appearance of moving. Thank you for watching.
And enjoy the game. This was Matthew Zita.
And Faris Kazmi.